to talk about arcs and chords. A central angle is an angle whose vertex is at the center, and then the arc is like the outside part of the circle that consists of 2 points as endpoints. So we've got minor arcs and major arcs. Okay, minor arcs are 2 letters, major arcs are 3 letters, and you follow the letters. Okay, so ADC would be from here to here to here. Okay, semicircle EFG would be 180. But arcs, you're going to follow the letters. If it's bigger, if it's 3 letters, then it's going to be usually bigger than 180. If it's 2 letters, it's going to be smaller than 180. You follow the letters. Okay? Minor arcs by 2, major arcs 3. All right, use the graph to find each of the following. Okay, so what is this asking us to find? An angle. Angle FMC. Well, angle FMC would be right here. So that's 9, 10, and 11%. So that's 30%. Well, 30% of what? How far is it all the way around? 360. So you take 0.3 times 360, 108 degrees. Okay? B, arc, M stands for measure. Measure of arc AHB. So we've got to follow the letters. A to H to B. So that's actually that all the way around. Well, that's 25% left over, which means that has to be 75%. Remember, central angle is equal to its intercepted arc. So we take 360 times 0.75, 270 degrees. All right? Angle EMD. EMD. So that's an angle. So we just, EMD is the little purple piece of pie. 10%. 10% of 360 is 36 degrees. Okay? So make sure you realize what you're dealing with, arc or angle. All right. Arc addition postulate. If 2 arcs are next to each other and you want the total, it's like the angle addition. You just add them together. So A to B and B to C would be the whole thing if you added them together. All right. Find each measure. Arc JKL. Well, we got to think now. JKL, just follow the letters, J to K to L. So it wants this arc right here. Well, this is a semicircle, so that's 180, and this is 40, so wouldn't from there to there have to be 140 degrees. Use what you know, figure it out. Remember, angles, central angles are equal to their intercepted arc. What about LJN? This is asking for arc L to J to N. So it wants from here all the way around. Well, I know that 40 and 25 is that. So if we subtracted that from 360, 295 degrees. Follow the letters, figure out what you're looking for. Okay, within a circle or circle, you can have angles, arcs, and chords. If those 2 are the same, then the chords, the blue lines, have to be the same. If the blue lines are the same, then the arcs have to be the same. And if the arcs are the same, then the angles are the same. Round and round we go. Moral of the story is, if they're all intercepting in the same spot and they're equal, then all the little pieces, parts about them have to be equal as well. Okay? Find NM. Well, we can see that the central angles are the same, which tells you that those chords have to be the same. So we go 14t minus 26 equals 5t plus 1. So 9t equals 27. So t equals 3. Plug it in. 3 times 5 plus 1 is 16. Okay? If one's the same, they're all the same. All right? PT bisects. So that tells you that these 2 are the same. This angle, that tells you that the chords are the same, so you could set them equal. All right? Not going to go through another one like that. I think we've got the idea here. All right. Once again, the chords are the same, so the arcs are the same, so you would set them equal. Good look at the section in the book if you're not seeing that, but after that, it's just algebra. And I know that all of you can do that. All right. Okay, one more, and then we'll be done. If you have a radius and a chord, and it bisects it, it's perpendicular to this, which allows us to make some right triangles to solve problems that look like this. Okay, so if you got a radius and a chord and it's bisected, it's perpendicular. So let me show you how this works. Find QR to the nearest 10. All right, this is QR right here. This is the radius, and that's 20, right? Well, wouldn't this line also be a radius? So wouldn't that have to be 20? Yep. So we've got a right triangle here. 20 is the hypotenuse, 10 is the leg. So we can do Pythagorean theorem. 20 squared minus 10 squared. Take the square root. We get 17.32 here. But that's here. It wanted the whole thing. So then we would take our answer times 2. 34.64 would be the answer to that problem. All right? Let's try that again. Solve for y, z. All right. We've got w to x is 12 and 28, so doesn't that make 40? So the radius is 40. So we're going to go here, which means that's still a radius, so that's 40. So I've got to go 40 squared minus 12 squared. Take the square root. And that gives me 38.15. But that's only from here to here. So to find the whole thing, I take that times 2. 76.3 would be the answer to that problem. Okay?